Hey guys, it's Mr. Hing here. I hope you are all well. In today's lesson, we're going to be touching on a broad overview of the rules of exponents. All right, there are 8 laws. There will be more videos coming out touching on other rules that you do need to know, like with square roots and that. But today, we're just going to be touching on exponents. All right, it's quite a long lesson, so get your snacks so that you are always able to focus. All right, please feel free to pause and make notes where you need to. So let's get started. Okay, so what you'll see is in number 1 and number 1b, right? We are dealing with the product rule. Okay, what does that mean? It means when there is multiplication. Now, in 1a, there's multiplication between, what can we see? We see we have the same bases. There's x and there's x. But now we have an exponent of m and an exponent of n. So what does the product rule say or mean? Well, we see the equal sign here. It means it's going to be when you are multiplying exponents with the same base but different exponents, we will keep the base the same, keep the x the same, and then you will add. We're going to add, right, the two different exponents. So let's have a look at what that looks like in an example. In an example, we have a to the power of 3 times the product rule, right? Times a to the power of 2. So what does the product rule say? When we multiply exponents with the same base, the base stays the same. So our exponent is a. Sorry, our base is a. So a will stay the same. And then our exponents are added to each other. So it's the 3 over here and the 2 over here. So 3 plus 2 equals 5, and that's how we get this answer. Let's have a look at number 1b. It is almost the same, but it is not. It's just similar. Okay, let's have a look. So again, it has got to do with the product of, but please have a look. The product in the example of 1b, we have the same exponent but different bases. So in this case, what will happen is you will simply just times the bases together. So x times y will do that and simplify it. And then we will raise it to the same exponent that we have on both of the different bases. So let's put that into practice and see in the example. So we have 2 to the power of 2 times, right, times 4 to the power of 2. What we see here is that we have the same exponent but different bases. So what did I say? We will simply multiply the bases together, the 2 and the 4, and we'll simplify that, and then we'll keep the same exponent, right? So 2 times 4 is 8, and we'll keep the same exponent, which is 2. So that is how the 2 comes over here. All right, so please make sure we understand this. What did I say over here? I said these are the easy ones. These are the really simple questions that they ask, which go for 2 marks, and all of us should be getting these right. Okay, let's have a look at number 2. So number 2, what I wrote here, it's the quotient or the division rule. The division rule. I like that. But some people call it the quotient rule. Okay, so what happens is, in this instance over here, we are dividing exponents with the same base. Okay, so it's very similar to the product rule. We are multiplying with the same base. Over here, we are dividing with the same base. So what do you think is going to happen? Well, we are going to end up subtracting. Okay, but firstly, just before I get to that, I want to show you this important step. In the test, if they give this to you, or if they give this to you, please remember it is saying the exact same thing. This is x to the power of n divided by, okay? And this is also the same thing, x to the power of m divided by, and it's x to the n, x to the n. So these two things here, this question and this question, is the exact same. So that's why I said they both mean. Now, in this rule, what happens is you keep the base the same, and then you will take the first exponent, which is m, and then subtract the second exponent, which is n. So let's put that into practice and see in the example. All right, so in the question we have a to the power of 8 divided by a to the power of 3. So all I said was the quotient or division rule says if we have the same base, a and a, we take the first exponent minus the second exponent. And there we go. It's as simple as that. A to the power of 5, because 8 minus 3 is 5. Okay, now remember, please remember, if this question was given to you like this, it is the exact same question, a to the power of 8 divided by a to the power of 3. So we do the same thing. We keep the base the same, we take the first exponent and we minus the second exponent, which is 3. And then 8 minus 3 is also 5, which will be a to the 5. Okay, let's move on to rule number 3. All right, rule number 3 is kind of called, I can write it down here if you like. It would basically be called, it's like a power to another power. All right, so what do we see here? We see we have a power or an exponent, and it's being raised to another power. All right, so what ends up happening is we have something in a bracket and we have a exponent or power, and it's being raised to another power. So what will happen is the power inside of the bracket will be multiplied. We are changing the sign to multiplication and not addition. So it will be multiplied by the power that's on the outside. Let's have a look and put it into practice. So the example is if we have a squared in a bracket to the power of 3, we can see that this 2 is being raised to the 3. Well done. So we're going to keep the base the same, a, and then it's going to be this 2 is being multiplied by the 3, and therefore 2 times 3 is 6. So this is how we get that answer. Okay. All right, rule number 4. Guys, just to pause there, as I said, if I'm going too fast, please pause, rewind. That is the luxury of YouTube. Okay, number 4 is what happens here is we have a bracket, and now what happens is we have multiple things or variables. Even if you have a number inside of this bracket, it is all being raised to a power. So what happens is actually every single thing inside of this bracket is going to be affected by the power on the outside. Okay, so what that actually means is the x will be raised to the power of m, the y will be raised to the power of m, and the z will be raised to the power of m. So let's put that into practice. Let's look at an example. So if our question was in brackets, we have 2 a squared b close bracket all cubed. So I drew these 3 red arrows here to show that they each get affected. So let's start with the first thing. So the 2 will be cubed, so equals, so the 2 will become cubed over there. Then we must apply the same rule over here. Please remember, guys, in maths, all the rules they almost like they all are related in some way or another. So if you see this rule and you need to apply it in a different question, please go ahead and do that. So this is a typical example. We have something over here, a squared, and a power is being raised to another power. So what is the rule? I said we end up multiplying them together. So the 2 will be multiplied by the 3. And then the b is also going to be affected. So another thing that you might not know, please remember this. I don't know if your teacher has taught you this, but if we have, let's just say in the tests, or I don't know, anyway, in your exercise book, they give you a letter. Please remember that if they don't write anything at the top here, there is an imaginary 1, okay, as a power. So why that is important is because this b has an imaginary 1, and the 3 will be times by that. So to simplify all of this, our final answer is going to be this. Okay, so 2 cubed is 8, 2 times 3 is 6, so it'll be 8 to the 6, and 1 times 3 is 3, so it'll be b to the 3. Okay, number 5. Let's go ahead and look at this. In this question, it's very similar to the fourth rule. So the rule number 5 is the same. Everything inside the bracket will be affected by the power. So let's have a look. So x will be raised to the power of m and y will be raised to the power of m. So a simple example is just if we have in the bracket a over b, a will be affected, so it will become a to the power of 3, and b will be affected, so that power comes over here, and it will be b to the power of 3. Okay, so we get to a point over here where we're starting to reach grade 9 stuff. So if you are in grade 8, you can skip rule 6 and 7. Actually, I would suggest, or rather stick around. It's really good to learn this, just in case. And then rule number 8 applies to everyone. So please note that for this type of rule over here and this rule over here, they are very similar. Okay, it's actually the reverse of each other. But before we get there, I want us to note something. So, when this exists in your workbook, right, please remember that. Let's have a look at this 3. If I have 3 like this, please remember that this 3 can also be written as 3 over 1. Okay, why? Because anything divided by 1 will still equal itself. 2 divided by 1 is 2. 5 divided by 1 is 5. So 3 divided by 1 is still 3. So please know that these work hand in hand. These are the same thing. Similarly, over here, a over 1 is the same as a. So, Mr. Hing, why do I need to know that? Well, let's look over here. The rule number 6 is that when we have a negative power and we need to simplify it, because in maths they always want the most simplified answer, what will happen is we will change this. Remember, what did I say? This can be written as basically 1 like that. And now what happens is, to simplify this, what will happen is you will take the x all the way to the bottom, right? You'll basically, yeah, you're going to take this to the bottom, and then you will change the negative exponent, which was -1, and you'll change it to a positive, and you will keep the 1 at the top as a placeholder. So this is how it works. So let's put that into an example. Let's say we have a test, and we get this literally for 1 marks or 2 marks, or 1 mark or 2 marks. Let's have a look. So we have this in our test. They say simplify. All you need to do is you bring this to the bottom. You make it a denominator, right? You keep the 1 at the top. You bring it, you write the divide sign, and you bring it to the bottom as a denominator. And your negative exponent becomes a positive exponent. So that it's as simple as that. In rule number 7, it's the exact opposite. It's the reverse. If we have 1 over x to the power of -m, and I told you when we're simplifying exponents, we don't really want a negative in our final answer. So how do we make this a positive? Well, we're going to bring this to the top. We'll bring it to the top, the x to the top, and we change the negative exponent into a positive exponent. Let's look at the example over here. We have 1 over a to the power of -3. So to simplify it, we bring it to the top, and therefore it will equal a to the power of +3. Okay, I hope we are starting to get that. Okay, and then lastly, number 8. All right, this one's super simple and super easy. Right, guys, the rule is anything. Look at this. Anything to the power of 0 is equal to 1. So in my example that I made for you, I made it quite exaggerated. Look at this amazing number that I put here. 25ABC to the power of 500 is all to the power of 0. What did I say? Anything to the power of 0 is equal to 1. Okay, so that is the final rule for today that we need to know. All right, and then I'm just gonna put a nice comment over here. Guys, please comment your questions. Okay, I really enjoy engaging with you guys through all your ups and downs and all your burning questions for math. So if you did not understand something, please put your questions in the comments section below so that I can actually help you where you're struggling, and I'll try get to it as soon as possible. But with all of that being said, I will catch you in the next video where we tackle some extra rules. Thanks, guys.